in this video, we will do some more tree examples. So the first example says that you and a friend are deciding a day trip location/activity. You pick a location, either Mendocino or Santa Cruz, and you write it down. Your friend then writes an activity based on the location. So here is a chart that displays what activities are available for you all to do in each place. So in Mendocino, you can either go hiking or you can have a picnic. And in Santa Cruz, you could go hiking, have a picnic, or go camping. Find the sample space of day trips. And by day trips, I mean what you end up writing down. So remember, you are writing down the location, and your friend is then writing down the activity. So that is the combination of things that you were writing down. And do this by drawing a tree. So I know this is a long word problem here. Definitely pause the video for a minute or two if you need to copy this thing down. All right, so let's start talking about it together. All right, so we need to make a tree diagram for this. So I'm going to start it off by writing the word begin. And then I have to think about what the stages of this are. So the stages of this problem are, well, it tells us that you are going to pick a location, and then your friend is going to pick an activity to do in that location. And then once we have those two things selected, we can then write down the outcome. The outcome will represent what's happening on this day trip. So for the location, we could either be in Mendocino or Santa Cruz. So let me just introduce some letters to refer to both places, shorthand. So let me call Mendocino M and Santa Cruz S. And then let me also pick some letters for the activity. So hiking, I'll call H. Picnic, I'll call P. And camping, let's call C. All right, so let's start our tree diagram here. So after we begin, we pick a location. So we could pick either Mendocino, which is M, or we could pick Santa Cruz, which is S. And if we happen to pick Mendocino, then we have two choices for the activity. We could either pick hiking, or we could pick picnic. If, on the other hand, we pick Santa Cruz for the location, then our friend has three choices for the activity. They could pick hiking, they could pick picnic, or C for camping. And that is it there. So we are ready to write down the outcomes. So if I do M and then H, we get outcome is MH. We could also have MP, and then we could have SH, SP, and SC. So we have those outcomes. And now we are ready to write down our sample space. So the sample space is just a set that contains all the outcomes listed within it. So we have MH, MP, SH, SP, and SC. So that is our sample space. So notice that there's 5 elements here in this sample space because we cared about the location as well as the activity that we end up doing. If the problem instead had just said the outcomes or the experiment just consisted of determining, well, what is the activity we end up doing at the end? Well, there's only 3 possible outcomes there because the activity could just be hiking, picnic, or camping. But in this problem, it did say that it wanted us to consider both the location and the activity. And that's how we have these 5 outcomes that we saw in this tree diagram. So let's look at one more example in this video. All right, so this example, but this one as well, it's a good idea to pause the video for a minute or so to give yourself a chance to write it down. But this example says you play a game where you flip a coin and record the flip outcome, whether it's heads or tails. We're not going to consider the small chance that maybe it lands on its side. The game ends either when you flip tails or if you flip 3 times. Draw a tree diagram and form the sample space of this game. So I want to begin by giving you the opportunity to try this question. So pause the video for 2 minutes to try this on your own first. 4, 3, 2, 1. Pause the video. Pause it for 2 minutes to try this one on your own first. Alright, so hopefully you've done that. Hopefully you paused it for 2 minutes to try this. So let's make a tree diagram to get us started. So I will write down, let's do it in black actually. So we begin, and then overall in this experiment here, there could potentially be 3 stages. We could potentially flip the coin a maximum of 3 times, because it says the game ends either when you flip tails, so that could potentially happen after 1 flip, or it ends if you flip 3 times. So maybe if you flip heads 3 times, at that point the game says, okay, stop. So stage 1, stage 2, stage 3, and then I'll keep track of the outcomes. So when we flip the coin the first time, either we get heads, which I'll call H, or tails, which I'll call T. So I'm going to call heads H and tails T. And then if we had flipped the tails, the game says, okay, the game is over. But if we had flipped heads first, the game would continue, and we'd flip again, and we'd either get an H or a T. And if we'd gotten a T, well, the game is over. But if we got an H, we flip again, and we could either get an H or a T. And at this point in either of these situations, we stop. Because if we got a T, well, the game says you end if you flip a tails. And if you got heads, well, we flipped 3 times already, so the game still says, oh, end. Okay, so the outcomes, if I consider all the paths, are one at the top is H, 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 3 heads. Or you could have H, H, T, H, H, T. Underneath that, we have H, T. And then finally at the bottom, we just have T. So this is an example where the outcomes involve different number of steps happening. Okay, so we are now ready to write down our sample space and put these outcomes in it. All right, so our sample space has H, 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 T, H, T, and T. So there are 4 elements in this sample space. So in terms of our goals for this section, we have now talked about how to use tree diagrams to list the outcomes of an experiment. What we're going to start to do in the next video is talk about how we can count the number of outcomes in a multi-stage experiment in some special cases really quickly using the multiplication principle.